To discuss fluid mechanics, we need to begin with the properties of fluids. Now, in this video, I'm going to discuss density, specific weight, specific volume, and specific gravity. So this is called rho. Now, when we talk about density, we are talking about mass per unit volume. Now, if you have some area, some volume, let's say you have a cylinder here and it has some the contents have some mass. If you take the mass per unit volume of this cylinder, you will get what we call density. Now, this can also be written in mathematical terms. In mathematical terms, we say that density rho is equal to mass per unit volume. Now, because mass is in kilograms and volume is given in meter cubes, the SI unit of density will be given by kilograms per meter cubed. Getting the volume is pretty simple. If you have a cylinder here, you will take the radius and you will take the length, and then you will calculate the volume as pi r squared multiplied by the length. If you have some cube, then you will have height, you will have length, and you will have breadth. Therefore, to get your volume, you'll take L times B times H, and then you get your volume, and then you take the mass, which is the composition of the material in your shape. You take the mass, you divide it by that volume, and then it will give you your density. Now, maybe if you are dealing with a less defined shape like this and you have your area is in a sort of a curve, and then you will use integration to find the area under that curve. Now, specific weight is represented by gamma. Now, this is called gamma, and this will be the symbol that we use for specific weight. Now, specific weight is different to density in that for density, we take the mass of our material, which is the composition of that material, and we divide it by volume. But for specific weight, we don't only take the mass, we take the force that gravitation will exert on that mass. Let's say again we have another cylinder here that has a length that also has a radius r. Now, because our material here has mass, now gravitation will exert a force on this mass, pulling it downwards, and we call that weight. Now, weight is the gravitational force that is acting on this mass, and we find it by taking the mass multiplied by the gravitational acceleration, which is usually 9.8 meter per second squared. So how do we define specific weight? We can say that instead of mass per unit, it is now the weight per unit volume. Now, instead of a scalar mass, which is just the composition of the material, here we take weight, which is the force that is being exerted on the mass of that material. Now, to represent this mathematically, we are going to say specific weight, which is gamma, is given by weight per unit volume. Weight is a force because we said that gravitation will exert a force on the mass. So our weight is given by newtons, while our volume is still given by cubic meters. Now, the SI unit of gamma will be newtons per cubic meter. This will be different in US units. Remember that this weight represents a force exerted by gravity on a unit volume of fluid. The relation between these two, as I said, this one is a scalar and this one is a vector. They have a relationship. Now that relation is given easily by taking this formula and then just making the volume the subject of the formula. So I will have V equal to mass over density if I take the volume and I make it the subject of the formula. Now that I have volume is equal to mass over density, I will then substitute it to this formula. Now to do that, I will have gamma is given by weight. Now remember that weight is equal to mass times gravitational acceleration. So I'll have mg over volume. I have made my volume subject of the formula here, so I will put mass over density. Now this will give me gamma is equal to mass density gravitational acceleration over mass. Now the masses cancel each other, and then we have gamma is equal to density times gravitational acceleration. Now specific weight is density times gravitational acceleration, and if we want density, this can also give us density is equal to specific weight divided by gravitational acceleration. It's the same formula, but it shows you the relationship between density and specific weight. Notice that your density will be absolute because we get it from mass, and mass is a scalar, so it only has magnitude. It does not depend on where you are, it just depends on its amount. Now for specific weight is a vector. It is not absolute, so it will depend on things like latitude, or it will also depend about elevation, because it comes from weight which acts in a specific direction, making it a vector. Now specific volume is volume occupied by a unit mass of fluid. Now with specific weight, we set weight per unit volume, and the weight represented a force exerted by gravity on a unit volume of fluid. Now if we take a unit mass and we check how much volume it occupies, we are now talking about specific volume. Now specific volume is reciprocal to density. It is reciprocal to density, meaning that to find specific volume, it is equal to 1 over our density. That's our another formula and formula. Now I'm going to use V for the rest of my videos for this because it's hard to draw this. It's called nu. It looks like a small v, so I'm gonna use a small v going forth because it will be difficult to write this down. But specific volume is volume occupied by a unit mass of fluid, and we find it by taking 1 over density. Now with specific gravity, it's denoted by the letter small s. Now specific gravity is just the specific gravity of a liquid is given by the density of that liquid over the density of water at standard temperature. That's all it is. The specific gravity is the ratio between the density of the liquid and the density of water at standard temperature. And those are your properties of fluid. In the future video, we'll talk about the fluid's compressibility and take it from there.